Okay, thank you everybody for joining October webinar. Today we have Tom Pike. I'm going to briefly introduce him. His main research area is the use of agent-based models to support policy development and using complex systems to understand the dynamics of resilient and robust democracies. He obtained his PhD under the supervision of Professor Rob Axtell at George Mason University and completed Complexity Summer School at Santa Fe Institute in 2018. I remember I met Tom at Santa Fe Institute at the time, and also a workshop, I think. He recently developed this amazing Mesa platform that people can easily use Python to make their own agent-based model. So Tom, please take the floor.
Okay, great. Thank you very much, Jen. So let me just say, I joined, so Mesa was started by Jackie Kazel and David Masad. And then I just kind of joined, I did my first contribution when I was at the Santa Fe Institute when I found a bug trying to make a model. And then I've just kind of been with it ever since. And so we got a pretty robust global team. Well, we got a global team of about 4 or 5 people right now that are regularly contributing. And so hopefully it's useful, but let's get started. So the first thing, so I put these links in the chat, but you can also just kind of search Mesa, read the docs, right? And it will take you to these links, right? And then on our page, just because if we use Colab, like we all have a common environment, you have to worry about Mac OS versus Windows OS versus Linux or what have you. So it just kind of makes sure everybody's on the same, in the same operating system, if you will. And that way, this tutorial will literally be, kind of going along through our introductory tutorial, our newly released visualization front end that was just put out. And so to get started, you just want to click on Open in Colab. This will, if you're not familiar with Google Colab, it's just a Jupyter notebook that is run by Google that has a lot of fun and fancy features, right? And that'll just take you to a Colab version so we can literally walk through the tutorial and talk about Mesa and its features. And at any time, if you have a question or you want me to elaborate on something, please feel free to jump on and interrupt me, and then we can talk about it. So, all right, so what we're going to do today, the introductory tutorial we did is the Boltzmann Wealth Model. Right, this is like a very simple model where you just have agents that give each other wealth, right? Some form of money. So they just, you're essentially just randomly exchanging wealth. Right, and then you see this kind of distribution of money that kind of randomly emerges from agents giving and receiving wealth to each other. Right? And then we should have enough time to go through our new visualization tutorial, and I'll talk a little bit more about that in there. So to get started, know that as we're going through this, if it doesn't have like a little, it doesn't have something like this, that's actually just part of the markdown instructions, right? So the tutorial is pretty long because we're talking, so you could do it in some kind of IDE like Visual Studio or PyCharm or Spider or something like that. All right, and so walks you through kind of these various different options. What this is in a Jupyter notebook or Jupyter Lab actually, and then we which just kind of makes it instant feedback. All right, so the first thing we have to do if you're running it in Colab, you first need to install Mesa. If you're not familiar with Colab, if you just put in or Jupyter Notebooks, you just put an exclamation point in front of it. That's telling the notebook to run the command. All right, so install it. I'll show you the visualization tutorial, how to make it so you don't get all this stuff. But here's the dependencies that we use. And then here, this is just more instructions. I can skip in this time that just walks through the different things of like, okay, if you're doing an IDE, if you're doing it in a text editor, etc., how you do that. All right, and we're going to use 4 dependencies for this. These 3, Seaborn, NumPy, and Pandas, are all part of the standard Colab build, so we don't have to worry about those, installing those. All right, someday, hopefully we get we could get Mesa to be a part of the standard Colab build. All right. So we import Seaborn, which is a visualization tutorial that kind of takes, if you're familiar with Python, the kind of common visualization library is called matplotlib. Seaborn takes matplotlib and kind of makes it prettier, right? NumPy is numerical Python, right? And so this is essentially puts everything in arrays, makes it kind of computationally more efficient, right? And then pandas, which is Python's kind of common library for working in columns and rows, so very good for data manipulation and analysis. Okay, so now to get started on the model. All right, so we've imported our dependencies. Yes,
Tom, I may be the only one having this problem, but I'm finding that my link to the Colab, the top of the page, I have visualization tutorial, and when I try to run the first runnable cell, it installs some Mesa and then crashes because it can't find a module called Mesa models. But I feel like I'm actually, maybe that link wasn't the right link.
Yeah, so that is not the right link. You want to make sure, and I'll talk about that in a second. Well, once I get to the visualization tutorial, we'll talk about that.
I see. I didn't scroll up far enough.
Yeah,
okay, so there are 2 links in the chat.
Yep,
yes,
2 links in the chat.
One. Thank you.
Yeah. So just to show, there should be a link to this. It says introductory tutorial and visualization tutorial, and then to Tim's question, just so you can see, it does actually work. And I'll talk about this a little bit more, but in essence, with Colab, we're running into how they're managing their permissions, and we have anyway. I'll talk about that a little bit more, but it's somewhat inconsistent. But more on that later. So what you should be seeing, you should not be seeing Mesa models yet, and there's it should just be pip install Mesa, and then import Mesa Seaborn pandas. Okay, are you good now, Tim?
Yep, I'm good. Thank you.
All right, awesome. All right, so now the next thing we're to do is create the most basic kind of pieces of a model, right? So, using just kind of standard-oriented programming, right? We're going to start with our money agent class, right? In this case, we're going to Mesa has an agent class in itself that gives you some basic functionality, right? So we're going to essentially inherit, or we are going to inherit that, right? And then we set up, initial, kind of standard Python syntax, initiate the class, right? Inherit the attributes from Mesa.agent, right? And then set up our one attribute for our agent, which is the amount of wealth they have, and we'll initialize that at just 1 unit of some type of wealth. All right, so that's one piece. All right, and so now we got to create essentially like the manager for our model, which is that manages the interaction of the agents and all the other classes that you might have. So this is kind of like a standard Mesa build where you might have one type of agents or numerous different types of agents, or another class that's just like a landscape, right? That provides the environment that the agents are living in. All right, and then you'll have essentially a manager class that initializes the model, creates all your agents, and then builds out and then controls how they interact with each other. Right, and you'll see that go out. So these become the basic building blocks that we're just going to now expand upon for the rest of the tutorial. Right, so you want to make sure you hit the little play button here. Right, so we created our agent class, we created our manager class, right, and now we got to add a scheduler. Right, and so just real quick, so you can see this is that when we initiate the agents, we're going to pass in one parameter, which is the number of agents. Right, and then we're going to in that number of agents, right, we're just going to create multiple agents. So whether that's 10 or 1 million, this will just iterate through this for loop and create that n number of agents. Okay, so now I want to add the scheduler, and this is going to control the interaction of who goes first, right? Like which agent goes at which time, because it is, computer program with Python. They have the global interpreter lock, so multi-threading is so you can do some workarounds to it, but it's effectively not allowed. All right. So we're going to take our agent class, inherit our models, initialize wealth, and then we're going to give them the step function. And so this is just kind of pure Mesa syntax that every agent must have a step function, right? And then the Mesa model will look for that step function and execute it when it goes through its scheduler, right? So the scheduler, looks for the step function and then executes whatever functions or actions are in that step function. So in this case, it's just going to print a sentence that says, hey, this is my agent. An easy way to do unique ID is just assign it a number as you're going through the for loop, which is what we did in the last cell, right? So now when we initialize our model, we have n number of agents, right? And then we create a schedule object. And in this case, we'll be using Mesa's random activation, right? We have a couple different activations. We got, well, if you ever want to see them, you can go through the read the docs. All right, so this is our read the docs, and we'll kind of walk through that. But just to emphasize this point, all our stuff is publicly available. You also can contribute if you're interested or find something that's annoying. But everything, but if you want to see the code or even change the code, in a second, I gotta move. It's all available, right? So in our time functions, in our time module, we have our base scheduler, and then each is a class on different types of activation functions. So the kind of common one, maybe the cheapest, easiest one is this random activation, right? But we also have simultaneous activation, right? Or staged activation, and then random activation by type. This is a somewhat recent feature, but they think like the wolf sheep predation model, right? Then you can, or if you have different types of agents, then you can activate, you can kind of create different ways to activate those agents based off the type of agent. And so I think, get out of this. Okay, yeah, so those are the different types of activation functions that we currently have. Right, and so it'd just be Mesa.time, random activation by type, staged activation, etc., right? But all right, so you create an instance of that class, and then you typically store it in something like self.schedule, but you can name it whatever you want. All right, so then we'll take our for loop where we iterate through, right, and assign each agent, essentially its unique ID, which is this I number. Right, so we'll assign each agent a number. We will add them to the schedule. And these are all just Mesa functions, right? So add agent to the scheduler, right? And then we'll advance the model by one step, right? So again, this is kind of just Mesa syntax where the main model will have a step function, and in that step function, it will call the schedule object step function, right? And that in turn then calls this step function. So to see that in action, make sure you hit the play key, if you will, right? Then you can run it. This, just real side note, if you're running this in like an IDE, an integrated development environment, and you're kind of building out different .py files, right? This gives you instructions on how you kind of do that by kind of common convention. So now that we have our agents, we have a model, they actually do something, the model calls the agent then prints out what its ID is. That's what these two lines of code do. So we call the money model object class, we're putting in our number, which in this case, we'll just put in 10 agents. That will create the starter model object, right? And then we're gonna call one step, right? And there we go, right? So, and then it just iterates through. You can see through the random activation function that what order they come in changes for each step. Okay, so we're gonna skip that, right? Then I think we'll probably skip the exercise, but we're trying to make our active learning. So we're trying to make our model more interactive, right? And this is an exercise to that end state where you would change, instead of printing it out, you would have it print out its attribute of agent.wealth, right? And so you create the same, you would create, just go through the same process where you would create an object model, right, from your money model, call the step function. And now instead of printing out, hey, I'm agent so-and-so, you could call me whatever, right? Now it would say, my wealth is, N number of dollars. And so now we're going to do agent step function, or we're going to increase it so it actually does something, right? Okay, so again, all we're doing at this point is expanding our agent class, right? So in this case, for our step function now, and this is just the way we wrote it, but you could put this whole process of events into another function and then call that from your step function, depending on your particular coding proclivities, right? But in this case, we're just going to say if the agent's wealth, right, is more than 0, right, then you're going to randomly choose some other agent, right, in the list of agents. So this just, if you go into your random activation, you'll see that really each agent object is just stored in a list, right? And so this will randomly choose one of those agent objects in the list, right? And if it's not none, this really, you could probably get away without having this. This is just like a catch to see if you have any errors, or to prevent an unexpected error, right? And then I'm going to take that other agent, give them some unit of wealth, and that will degrade my wealth by 1. Okay, so again, just a kind of random model, right? And so next, right? So now we're going to just, go through the same process. Previously, this was called starter model. Now we're just going to call it model, right? And then we're going to call our manager class money model. We're going to instantiate it with 10 agents. And now we're just going to build a simple for loop to run through 10 steps. All right, and so now the model runs. Okay, and now we got to see what's happening. So if again you're running an IDE, you could just use this code. But for Jupyter notebooks, we use the magic command. We use the magic command, which is I think that's the magic one-liners, which is what the % means, right? So we use the standard library matplotlib, right? And then we'll print out what the wealth distribution is in a histogram. Right, so just run that, right? And there's our wealth distribution. Right? And it's super easy. So now, all right, we can run it again, all right? And we'll get another wealth distribution. Okay, so are there any questions at this point? All right.
I did have a question. So you've done it for Jupyter, you've done it if you're doing it in an IDE, etc. Does it hurt it if, because I noticed there's some extra lines for Jupyter, right? But I mean, if I'm just copying and pasting that across and doing an IDE, is it just going to throw an error at me? What's going to happen?
Yeah, if you directly copy and paste, it will do. You got to follow it. However, all this code is also stored in this. I go to the main Mesa repository, and I'll throw this in the chat here in a second. So Project Mesa, right? So all of this code is also stored in Mesa examples. And what we're going to see in the visualization tutorial, and just kind of based off the issues with that Tim alluded to with installing it directly from Git and then having some essentially permission errors with Jupyter Colab. I think probably the next 2 weeks we'll get Mesa models released as a library, and then you can see all those things. But if you want to just see the various, so if you just want the Boltzmann Wealth Model, it's all in here, right? So if you want to run it in an IDE, it's all in our Mesa examples folder.
Thank you.
Okay, yeah, so that's the wealth distribution. Okay, so now, okay, sorry. So in this one, I should have pointed this out, right? So now we're gonna, what we do here is, because you want to run the models, explore the parameter space, so we're just gonna create an empty list. We're now, you're gonna run the model 100 times, each model with 10 agents for a range of 10 steps, right? And then we're going to plot out what that wealth distribution looks like. Right? And it's fairly easy, so now I want to make, 100 agents for 10 steps. And I just run it through. All right, it takes a little bit longer, but here's 100 agents, 100 running the model 100 times with 100 different agents. Okay, so then another feature of Mesa, so that was really like the scheduler and getting visualization so you can start to analyze the data that's coming out of your models. And so now we have another class called Mesa.space, right? And you can get all the codes open for auditing, if you will. So we want to create that. And so now with Mesa models, so now we're back in the manager class, the money model, right? And so just like self.schedule, we created that object. In this one, we're going to create a multi-grid. So we have a couple different ones. So just to always emphasize this point here, is that if you want to see all the classes, you could go through the documentation, right? Or if you go into Mesa and you want to actually see what the code does, you go into Mesa space, right? And then this will walk you through the different options that we have. We have grid, but that's just the base class, and then single grid, right? And so this strictly enforces 1 agent per cell. Multi-grid, this allows you, so if you have an agent that's like Sugarscape, so you have a sugar and spice in an agent, right? And then a trader agent can be in that one, right? Then you use multi-grid. You have hex grid, right? So that is hexagons for your shape instead of the square, which has some distance implications, right? We have continuous space, right? And then we also have one that's using network X, which is purely based off your kind of the space that you're in as a network, right? So these are the different spaces that are available through Mesa. All right. So in this case, we're going to do multi-grid because we want more than one. We want to allow more than one agent in. We're going to increase the number of our parameters. So now it'll be number of agents plus the height or width and height of our grid, right? So this just follows a standard kind of XY convention. All right. And then we're going to create our agents. We're going to add them to the schedule. And then similarly, we're going to randomly assign them to some X point, some Y point. So some part of the width, some part of the height, on the Y axis or height, right? And then we're going to place the agent, right? So in this case, there's the A is the agent object. And then where that agent object goes is this X and Y coordinate. Run that. Okay, and now we're going to add another, actually down to the code. Okay, so now we're going to expand our agent class so that it'll actually move. So we're going to create a function called move, right? We're going to use one of Mesa's built-in functions called get your neighborhood, right? Here's a couple parameters. So what's your position, right? And that'll just be where they're at in the grid. So it will, Mesa will find that since we didn't actually assign as an attribute. Whether you want the more, so like all 8 cells around you are the von Neumann neighborhood, right? So true, and then another, it's another quark or keyword argument, as we can say, okay, we don't want to count the cell that we're in, so we're not going to include the grid that we're standing. Right, and then they'll randomly choose. It's a very simple model. They'll randomly choose where they want to go, and then they'll move to that new position. Okay, and now in this case, we'll now take the function out of step, right, and put it, or the function of exchanging money out of the step function and make its own function called give money, right, and we'll look and see if anybody is in our grid cell, and if they are, then we will randomly give them a piece of wealth. Okay, so now our step function looks a little bit simpler, and so as call, it'll do the move function, and then if they have wealth, right, then it will then they will execute the give money function. Okay, so now I've updated our money agent class to both allow them to move, right, and allow them to give money. I guess we had that before, but so And then just to reiterate the money model, what we do, we instantiated self.grids. So we said the multi-grid object, right? And then when we did our initial for loop, we added people to the schedule, and then randomly assigned each agent to a place on that grid. And then we just call the self.schedule.step function, and that will randomly reassign the order of the list and then execute the list one agent at a time. All right. So now that we have 3 parameters, we're going to instantiate a model with 100 agents on a 10 by 10 grid, and we'll run it for 20 steps. All right. Now in this one, so we can visualize it, what we're going to do is just effectively plot a heat map, right, using Seaborn that shows what's the distribution of wealth for the or how many agents are in each cell, right? So we got a lot of cells with 0, some cells have 5, 4, 3, and so this just tells you effectively how the agents are distributed across your grid space. Okay, again, super easy to, or fairly easy to change stuff. Let's say I want a 20 by 20 grid, and I want 500 agents. All right, so just run it. Run this. All right, and now you have a 20 by 20 with more agents. All right. So now we've how to do an initial model, how to add the scheduler. Right, where we have things like random activation by type, staged activation, simultaneous activation, right? And then that was a quick overview of the space tutorial, where you can identify what kind of environment you want them to work in, like networks, single grid, multi-grid, hexagonal grid, etc. All right, but we also have a data collection function, right? So another one of our subclasses is data collection, right? And so again, just like all the previous ones, this will walk you through what features our data collector has, with lots of documents, with lots of commentary on our kind of thought process on how we set that up. All right. So in this case, the Boltzmann Wealth, we're going to create a function to compute the Gini coefficient, which is just a statistical measure of wealth inequality, where 0 is perfectly, all agents have exactly the same, and then 1 is like the most unequal distribution of wealth. So like one agent has everything and all the other agents have nothing, right? So this is just a function to compute that as a macro level, process, or as a macro level metric for the wealth distribution of our model, right? And then this, this follows as nothing. So I think this is all the same. The one difference is when you initiate data collector, right? You create a data collector object, right? Just call the data collector class. You can have a model, so you have model level reporters. In this case, it's going to be Gini, and we're going to call the function compute Gini, which is right up here. So that's what we just went over. All right, we pass in the model as a parameter. All right, and then we also have agent level reporters. So in this case, we're just gonna, they really only have one attribute. And so in this case, we're just gonna see how much wealth they have, right? And then if you wanna collect it for each step, so if you just do data collector and you don't add this, then it'll just give you the kind of, its end state, if you will. Right, but if you do data, if you want to collect each individual step, then you use data collector .collect. All right, and so then again, run the model, right? 100 agents, 10 by 10 grid for 100 steps. Okay, and now we're going to call back the data collector to get the data that it collected. So first, we'll get the model level reporter, which is Gini. Right, so we just use the data collector function, get model vars data frame. Okay, and then that gives us the Gini coefficient. The way we plotted it, just use a standard line plot for ease. That gives us the Gini, how the Gini coefficient went from 0, to around 0.6, 0.63 or so, over the 100 steps that we ran it on. And then if you want to see, what all the data, right? This is just printing it out in a pandas data frame. Is that you can get the agent vars, and that would give you what step number it is on, the agent IDs, all right, plus how much wealth they had, and for whatever attribute you're collecting on, this can be expanded, to your heart's delight, if you will. All right, and then we can see the distribution of wealth at the end of the simulations. This is just a simple histogram to show you, number of agencies and the frequency of wealth occurrence. Right, and then if you want, this code just walks you through. Okay, I want to track the health of one agent over time. So this is agent 14. Right, change that to 42. All right, and so you can see how the wealth changes per each step of the iteration. Right, and this is all just to demonstrate the capabilities, which is so with data collector, you have model variables and you have agent variables, you collect it, and then with Python's kind of rich data ecosystem, there's lots of different opportunities to plot it in different ways. So is there a question? Okay, all right, so that's the data collection function. All right, you can also, I'm not going to run this, but if you run it, it'll save it in this folder section here. Right, but if you want, it's fairly easy to export all this to a CSV. So if you want to now put it into a different environment or put it in a, do whatever, you can just extract all the data to analyze it at your leisure, or just store it for later. Okay, the final class in the introductory tutorial is going to be batch run. Right, so you got to be able to do parameter sweeps, so you could try different, see what that kind of each space looks like, contingent on the parameters. Right, so this model walks through that, or so this code now adds that feature in there. Right, and really to run batch runner, it's pretty much it's the same model, and then batch runner kind of gets layered on top when you instantiate your first object. All right, and this is just all the parameters that you have, and walks you through, how to set it up, which we'll show you here. So you pass in the parameters as a dictionary. We're going to keep the height and the width and height the same, right? And then we're going to change the number of agents from 10 to 500 at increments of 10. So 10, 20, 30, 40, 50, 60. If you're not familiar with Python, you actually stop at 490. I believe. I don't think we're going to get all the way to 500, but could be wrong on it. And then we'll run, and then to run batch run, we'll call, call the batch run function. We're going to pass in our money model. We're going to pass in the parameters. We're going to run each iteration, right? So each set of number of agents 5 times for a maximum number of 100 steps. I think Google, even if you change this, Google Colab will restrict you to 1 processor. But if you're on like a machine with multiple cores, so say 30, 40 cores or whatever, you can max that out, right? And then essentially you'll just use every core to run your model, right? And then you can specify your data collection period, whether it's every step, every 5th step, every 10th step, all right? And you can display a progress bar. So if we run that, right, this will give us 245 iterations, right? And then then we can look at the results. So as this will kind of wrap up that part, and then we can switch to the new visualization stuff. Are there any questions before, as I guess the batch run is running?
Hey, Tom, quick question. When you say the new visualization stuff, are you talking about the changes with Mesa 2.0? I did a lot of Mesa 1.0 work last summer. And so kind of the changes are what I'm particularly trying to key in on here, because I haven't touched Mesa for about a year now. Okay, yeah, so just this past month, actually our most prolific contributor, RHT, built out a front end using a new library called Solera. So now our whole front end is in Python. So we still have the JavaScript based version, all right, but we now have
one that's all based in Python using this very cool library called Solera. And so yeah, so that's what's really new. We made a bunch of other changes, like random activation by type, adding in data collection, improving the data collector so it's easy to determine if you want to just collect specific agents. We made some backend improvements to make it slightly more performant. But kind of we found talking with our user base that academics is probably, at least our as far as we know, our most not scientifically collected, but our most active user base. And after we did some other things like make the namespace easier, so it's more intuitive, so you can just do things like Mesa batch run. The other thing they said was like, hey, we really need a better visualization that's all kind of Python based, because the JavaScript, particularly for new coders, was really turning some people off. And just recently we found, actually Solera reached out on one of our GitHub pages, and we tried it, and it is working phenomenal. Although as you'll see in a second, there's just some Colab issues, but everything else is good. And that's just to emphasize this point, because it is, I will emphasize, despite it being awesome, and I'm a big fan, I will emphasize that it is, relatively new. So kind of following common developer convention, it's all locked out here, or it's all kind of written here in experimental. If you have feedback issues, you can easily open up an issue on GitHub, and that will help us to improve it. Did that answer your question, Clark?
Yeah, it does. Thank you very much. And I've spoken to RHT on the GitHub before, and I was talking to Andrew Cooks about this. Is he or she still a mystery contributor?
Who, RHT? No, I mean, I know who. I mean, yeah, he. I guess he's very. I forgot this. I guess he definitely likes his privacy, but I mean, he's not fine. A mystery contributor. Yeah. So okay. Yeah.
Thanks.
Yep. Right. So we ran our 245 iterations, right, and then we'll just use pandas to print out, to get our data frame, so then we can analyze results. Okay, and then this just gives you so this just gives you a plot of what the Gini coefficient versus the number of agents, the number of agents on your x-axis, Gini coefficient on your y-axis. Right, where you can see the Gini coefficient kind of, settle down here between 0.6 and 0.7, as once it kind of reaches, probably like 30 or 40 agents. And just for the sake of time, this just gives you more things you could do to, analyze all that data. All right, so now we'll switch to the visualization tutorial. All right, so this is new. Again, you just have to open up Colab, right? And then this will take you to a version. So the challenge is right now we have not released Mesa models on PyPI, so we're installing it we're installing it from GitHub. What I learned was we thought we had this fixed, but apparently, as I was messing around with this morning, getting prepared, it seems like you almost have to run this twice, like for it to work, right? Long story short, if you're running it in just your local Jupyter notebook, or you're running it in an IDE, where we have lots of, again, you could see some examples in Mesa.examples or Mesa-examples. You won't have any of these issues, but from what I can tell, it seems like you. So here's yeah. So in the examples, right, if it has the experimental tag, right, then it will work through an IDE, right, and that's with the new front end visualization. So I'm not going to run this again. This is not, you're not going to see this code, but this is just me trying to debug it. What we'll do is I'll make sure we get Mesa models released to the Python package index, and we will update this, and that should be within the next 2 weeks. That's actually pretty easy to do. We just have to do it, and then instead of being pip install from GitHub, it'll be pip install Mesa models, right? And then you won't have any of these like kind of permission access errors, because effectively what's happening is Mesa models is being stored locally in Colab, and they don't necessarily reference that file, and it's causing some issues. But if you don't use that, and then it changes of whether based off what parameter you use. So the best I could tell, kind of messing around with this right now, is if you're in Colab and you kind of run it through twice, where you restart your runtime, then for whatever reason something happens on Colab's backend and it works. All right, but for Mesa models, or for the visualization, this just walks you through for the Boltzmann Wealth Model, right? So that exact same code we just went through, right? Actually, in .py files, you would have, your agent portrayal. The other way to do it is if you just add this code to the intro tutorial at the end, it will also work because all that code will be locally stored, right? Then you set up your model parameters, right? So again, kind of standard. We're going to create a slider, right? This is just Solera kind of documentation, or we go up to 50 agents. We'll give it this label, or sorry, it's going to start at 50, right? And then it's going to go from a minimum number would be 10, maximum number would be 100, right? That'd be at step 1, and then we'll, initiate our kind of standard 10 by 10 grid, right? And then again, this is, 3 weeks old. So we have it in Mesa Experimental, right? And then we just called it Jupyter Viz. And so then actually, I think this is from Solera. So then you import that, we're calling the model Boltzmann Wealth Model. And so if you're doing an introductory tutorial, you would change this to money model, right? And that would reference that model object. You pass in your parameters, your same kind of measurements, and then give it a name. And then for agent portrayal, we're just going to use this agent portrayal function here. All right. And so then when you run that, this is what it looks like. Right. You got a slider, right? It goes up to 10 to 100, right? Kind of updates in real time. Hit the play button, right? And then it just starts stepping through. All right. I believe if you do it in the .py, that should just open up a new window, like a browser-based window, and then you can run through it. Got kind of like the standard functionality. We can step through it one step at a time. Okay, then if you want to, so this is just now expanding on it once you set it up. So now we're gonna make our agent portrayal more exciting, right? So it's gonna start as standard size 10 with red tab. If your agent wealth is above 0, then you go to 50, all right? With color blue, right? And then you just return the size and the color. And then we run the same function again. Right, and so if you're familiar with so Clark, to yourself, if you're familiar with the things, Mesa previously, this then is exactly the same functionality as the JavaScript-based front end. All right, which we still have that tutorial up there if you want to go through. Right, but this just shows you, kind of gives you some, if they have, which agents have wealth and which ones don't. Okay. Now, because it's using, our goal is just to exploit as much as possible the rich Python ecosystem. And so in this case now, if you want to add a histogram as an example, this kind of walks you through how to add additional things into your model, right? So you get this. Let me see if I can. Right. And then it starts walking through. Right, and now we got so now this just produces a histogram that that we added through this function. All right, so you can see how kind of the wealth value is changing. For each step. All right, so that's our hot off the presses new front end, currently under the experimental folder, and until we get some more usage on it and make sure it's robust and resilient. And then that will become part of the standard build for the Mesa front end. All right, so we got like 3 minutes left, but are there any questions, comments, or concerns at this point?
Hey, Tom.
Yes.
Yeah, so I have a question. Actually, this is my first time I have seen this platform. So originally I am used to use the Java based platform. So my question is there any in general framework for this platform, like any object based framework, like for agent based model, like how we can define the each agent, their environment and their interaction? I mean, I see that every time you run the model through some loop, and anyway, maybe you have, but I did not get the sense that is what is the in general framework for this Mesa.
Yes. So it's all objects. I will make a shameless plug, and I think we're coordinating to have this set up later for particularly more robust environments that are kind of based off in the real world. We do have Mesa Geo, which is quite a bit younger than Mesa, but I know Andrew, Dr. Andrew, or Professor Andrew Crooks is one of his PhD students is working on that if you need a GIS extension. And then I think to answer your question, everything in Mesa, hopefully I'm answering your question, but if I'm not, let me know. Everything in Mesa is an object, right? So every time you call something, well, for the most part, every time you call something, it's going to be an agent class. So if you want to, create whatever an agent-based model that's based off cells, right? Then you can define that class however you want, right? And then when you build your agents, you just make that a class. So I mean, let's see if I get this right. We try to exploit the essence of object-oriented programming in all aspects of Mesa, and it's so that way you want to make a standard agent, you can make whatever class you want for whatever agent. Does that answer your question? I'm not sure I'm understanding.
Yeah, I got it. Yeah, that's the power of agent-based model, that we have flexibility to define our agent in our own way, and we can define our interaction of agent with environment with our own way, or based on our sense, right? But even there is a in general framework. I mean, like defining agent, defining time step, and defining environment. And then the estimation procedure can differ from one model to another, but some quick thing, framework or quick things that we can grasp easily. Is there any? So I'm very new, actually. That's why maybe my question may be very layman question.
Yeah. So and I'll tell you this, I got to update these right now, but so this is my pet project. It is not, and unfortunately with my current job, I don't have the time to really work on it, but I can update these. What I think, to your point, we try and make Mesa as extensible as possible, where you can build whatever class, whatever you want. All right. But that there's always this trade-off between, like, well, how much stuff am I reusing, where like starts to lock down the flexibility of that framework versus like having the most bare bones framework possible, where now you got to do a lot of extra work just to get to a working model. So what I started, I got a paper in Simulation Journal that talks about this. What I'm advocating for, just with the dynamics of GitHub and open source coding, right, is that there's essentially a rich ecosystem of that people are contributing to that allows people to have kind of stuff ready-made. So this, and again, it's got to be fixed because they or need append to dependencies. But this allows you to get data from NASA and some other places, so you can assess crop yield, or so you can kind of put environmental data into a geographic area. This uses worldpop.org to create a synthetic population. So that way it's like, hey, I want a population that's more realistic. What is the number of males, females, children, et cetera, if you're like trying to deal with like a youth bulge or something like that. And so this pulls out those, so this tries to build data pipelines, for that. Same with this was like behaviors. So this is a SIR model that me and one of my colleagues threw together at the beginning of the COVID pandemic. So it gives you your standard susceptible infected recovering methodologies. This one, if you've heard of the bilateral Shapley value of cooperative game theory, and that one really needs to be updated. It's a little bit hanky, but the idea would be that, let's say you've got behaviors that you're using over and over again, right? It's like, well, let's make that available to everybody. So now if I need the behavior of a 6-year-old in the COVID pandemic, it's like, okay, they're probably not going to wash their hands well enough versus 15-year-old. Now I can have those behaviors kind of ready, that I can import or that a community can improve. So this is very much a nascent idea, kind of capitalizing on the machine learning ecosystem like TensorFlow and scikit-learn. And what I've learned from this is that it's an order of magnitude harder because there's so much when you an agent-based model has so much more you have to worry about than, say, a machine learning model, where it's just that what's methodology using like a support vector machine, and then your biggest problem just becomes the data, right? So I guess to answer your question directly, we try to make Mesa as bare bones as possible to provide the most flexibility so people can build whatever model they want. Like, what's the key core functionalities that we need, right? And then, but we also know it's like, well, I want to try and understand this phenomenon. How do we have essentially add-ons or extensions that people can import, so they have the most flexibility to go as unique and bespoke as they want, all right? Or just have like a ready-made set of everything from data to behaviors to whatever else that they can put together for a specific situation that they're concerned about. But that's, yeah. So there's a very long answer to your question, but hopefully it was helpful.
Yeah. Thank you. Thank you so much.
Okay. Are there any other questions?
I have a question. It's Andy Collins here. So yeah, this is awesome. When you first saw your tutorial years back, when you had the visualization piece, that was a big concern for me at the time because it was something that turned me off, I'll be frank with you. But now you've got that in, that's amazing. I'm really impressed with the progress you guys made. The question I got for you, so with the Colab not working for the visualization piece, what would be for a dumb actually I was about to swear, I won't swear in front of you, but for a not very smart person like myself, I mean, what would you suggest is the best way forward to do a test on this sort of like visualization?
Yeah, don't do it in Google Colab. If you run this code in your local notebook, it will work.
It will work. Okay.
Yeah,
okay.
You won't have this problem.
Okay.
Yeah, and then the other bit is, and I'm saying 2 weeks, hopefully to give ourselves enough time, but we will release Mesa Model 0.1, right? And then I will update this tutorial, and it will just say pip install Mesa models, and then this will work as well. So
basically,
like
hang on for a couple of weeks is probably the easiest thing to do. Yeah.
Yes. Yeah. If you hang on for a couple of weeks, then I'll be good.
All right. Thank you. No, I appreciate that.
Yeah.
You did somehow make it work, though, right? On your screen, it works. On my screen, it doesn't work.
Yeah, and I mean, honestly, that's what's kind of confounding me and making me very upset. So I've messed around with the e-variable, and really, and this happened the first time I did. I thought we had solved it, which is where this code came from. But it seems like if I just like either reset the runtime, right? Like hit that. And then run it again, it works, or I just, so like messing with the runtime seems to make it work, and I'm not sure why.
Right. No, maddening.
Yeah. But if you run this in a local notebook, it will work, but we'll get Mesa models released, and then this won't be a problem.
Cool.
And the final, so I give a quick shameless plug, it seems like I'm not sure there's any more questions. But, and this will be updated in a couple of weeks as well, based off, probably add the visualization and fix a bug or two that don't have a substantial impact. But through Complexity Explorer and the Santa Fe Institute, we do have a tutorial. This is a much more involved tutorial that uses, if you're familiar with like the kind of seminal Sugarscape by Axtell and Epstein, this walks through a variant of that, which is Sugarscape with traders, right? And this also uses Google Colab. And it's roughly, and it just runs you through where we stopped kind of the introductory tutorials, which is a batch run. Maybe I'll add in the visualization stuff. But this one, this will walk you through a much more involved model that is kind of, it seems like you always have beginner models, and then it just like kind of stops after that. So we're deliberately trying to get like an advanced beginner model that was much more involved. And so based off, graduated from George Mason, we're like, let's do Sugarscape for traders. And I think particularly once we update some more features on it, this is probably the most accurate one to the Growing Artificial Societies book that it comes from. So I can put that in the chat too. So are there any other questions?
Okay, if there is no question, I have announcement that there will be a Mesa Seek session at the conference in Santa Fe this year. That's right, Tom, is that right?
Awesome, yeah, that's right.
Yeah.
Yep.
Yeah, so we will have an annual conference Santa Fe, November 2nd to 5th this year. It's usually autumn in Santa Fe is beautiful, so I hope you all join us, and also SIG session that run by Tom Pike again. And also our paper submission deadline got extended to August 11th. If you have a paper, any research, write up quickly and submit. And then I really hope to meet all of you in Santa Fe this fall. Okay.
Well, let me add one thing to that.
Oh,
just
yeah,
so
sure.
you don't necessarily have to listen to my marble mouth again. Boyu Wang will also be there, and we'll be talking Mesa Geo. And then, depending on everybody's familiarity with it, we'll try and customize that tutorial so it optimizes people's interest or what they want to try and get out of it.
Yeah, that's great. Thank you for sharing that. And we will also host Mesa Geo probably next year, February, at our webinar. So stay in touch, and thank you for joining today, everybody. Tom Pike, thank you so much. And then I will see you hopefully next webinar. Thank you. Bye.